Okay, so I think a number of people have joined in, so we are good to go. Okay, so hello everyone. I'm Shreya, and I will be taking your session today. In your previous sessions, you have been introduced to competitive coding, and we had discussed some tips and tricks as to how you can solve these questions. So from today, we will be starting with DSA. DSA forms the backbone of competitive coding as it optimizes your code. And other than the, competitive coding, DSA plays a very important role in your placements. A number of you must be in your second year, and so as you go to your third year, you will be sitting for your internship exams and placement exams, and DSA will be quite important at that time. So let me just share my screen. I'm audible, right? Could you please type in the chat box? Okay, so can you see my screen? Okay. So, DSA, I think most of you have completed your DSA course by now, and you must be knowing what stacks are. So, I'll be giving a brief introduction of stacks, the basic operations of stack, and then we will be moving on to some questions. They will be basic nested looping questions, and we will be discussing the stack approach to them. And why is the stack approach better than them, and why should you use this approach? So let's get started. So what is a stack? Stack is basically a linear data structure. When I say linear data structure, what it means is that the memory is allocated just after the other, like it's a continuous memory allocation takes place for stacks, and it works on the principle of last in, first out. So when I say last in first out, what it means is that, for example, you have a pile of plates, and you have a pile of say 4 plates, and then you have to stack a fifth plate on top of the 4 plates that you've been given. So you will take the fifth plate and place it on top of the fourth one. And now if you have to remove the if you have to remove the plates, the fifth one that you've just put in, you will remove that first. So what it means, the last one that went in is the first one to come out. So this is the basic working of stacks. This is how stack works. So let's go to the coding part. So when it comes to coding, so we are going to use these variables. St will refer to my stack array. N will be the maximum size of the stack. Now, interesting factor is that in a stack, we keep a pointer called the top pointer, which points to the topmost element of our stack. So, over here, we will be initializing it with -1. But however, you can work with 0 as well. But I generally use -1, so I will be working with -1. When we go to the functions, the first function that we need to check is when is a stack empty. So our stack is empty when it's in its initial condition. So when the top pointer points to -1, which was our initial condition, we will say our stack is empty. So we'll return the boolean true or false. If top is equal to -1, we'll return true, else we'll return false. Now another function that we need to check is the full condition. So when is a stack full? So a stack is full, like you can see on the right, there's an example where it's a condition of the stack given is full. So the top pointer is pointing to the last element, which is E over here, and the top pointer will basically contain the value 4. So when the top pointer points to n minus 1, basically like 5 minus 1, 4, so we'll say our stack is full. This is simple. uh, Let us move ahead. So the push operation. So when I say push operation, it basically means to add elements to your stack. So As I said before, it works on the principle of last in first out. Here we will be when we push elements to the stack, we always push from the end. Yeah, so before pushing, we will check if the stack is already full. So now, if my stack is full, I cannot add elements. So we'll check for the is full condition and throw appropriate error message. And then we will first now look at the example on your right. Say top is -1. So this was my initial condition. Now I have to push an element to our stack. So I increment the top pointer and then I add element like st of top is equal to element, which is a over here, and then this is it. So for example, if you have to add another element, now your top pointer points to the first element, which is top is equal to 0. So you'll be doing top plus plus, which makes the top pointer move to 1, and then you will be adding an element at the first position, first index basically. Now, an interesting point to be noted is that the time complexity of the push operation is O of 1. Okay, we'll move ahead. Now the pop operation. So pop operation, what it means, like let's go back to this plate example. So you were asked to remove the topmost plate. So you remove the fifth plate and return the plate, and now the stack contains of the four plates. Where is the top pointer pointing to? It's pointing to the fourth plate. So this is what pop operation does. It removes the topmost element and returns it, and now the topmost element will be the second last element basically. So, and obviously if your stack is empty, you don't have any element there, so you cannot return anything. So I've returned arbitrary hash like arbitrary character which indicates that my stack is empty over here, and then I will look at the right, look at your right. This is the stack which is which I need to pop an element from. So I will be first storing this variable in a this element in a variable, and then top was 4 initially. So I'll decrement the top pointer. Now it has to point to the second last element, and then I will return ch. And another thing to note is over here also the time complexity of the pop operation is O of 1 as well. So that's it with the basic operations of stack. I'll take a pause here, and then if you have any doubts, you can throw it in the chat box. Yes, Dhairya, we will be discussing problem solving questions using stacks. I think you guys don't have any doubts, so we can move ahead. So now, as Dhairya asked, what kind of questions can we expect in problem solving? So, so first question comes is when should you be using stacks? So, not all. There's no generic case basically that if the question is of this type, you can apply stacks. There's a pattern that you need to observe in the question. So, like if the brute force approach works in such a way, look at the loop that I've written here. For I is equal to 0, I less than n, I plus plus. I'm audible, right? Yeah, I'm audible. I guess my mic is on. Yeah. Okay. So I is equal to 0, I less than n, I plus plus. Now this nested loop, the j loop runs from I to n. Less than that means n minus 1. So j is equal to I, j less than n, j plus plus. If the loop, the brute force approach, is solved by using a loop of this case, this type where the second inner loop depends some in some way on the outer loop, then there is a chance that we can use stacks to solve the question. So why should you use why should you use stacks? Is we'll come to that later on. Let's see. Okay, so here's one very basic question. You've been given an array of numbers, say 10, 5, 12, 6, 7. You need to find the nearest element on the on the left of the number which is greater than it. So for 10, since it's the first element, so there's no other element on its left, so we will be printing -1. Now for 5, there is there is 10 which is greater than it, just before 5. So we will be printing 10. Now for 12, 5 is less than 12, 10 is less than 12. So there's no other element which is greater than 12. So we will be printing -1. Now for 6, we see 12 is greater than 6. So we print 12. For 7, we again check for 6. 6 is less than 7. Then we check for 12. 12 is greater than 7. So we print 12. Now, when you look at this question, the first thought that comes to your mind is I can just use two loops and solve the question. So this would be your basic brute force approach, that you will run a loop and then you will store the value and then you will check, like for this 7, you will be running a loop in the reverse order from 6 to 12, 6, 12, 5, 10, and then checking if the number is greater than the number. So and then break it. Uh, this gives a time complexity of O of n square. But if, for example, if you have to work with in competitive coding, if you have to if you're solving questions on Geeks for Geeks or on HackerRank or any other competitive coding platform, CodeChef, Codeforces, they will obviously always ask for a more optimized solution, because the array that they will be giving in the test cases will not contain of 5 or 6 numbers. They will be containing hundreds of numbers. So the time complexity becomes quite large there. So we'll look at how we can optimize it using the stack approach. Uh, Here you can see the array that we had initially taken: 10, 5, 12, 6, 7. And on your left, you can see the empty stack that I've initialized. Now we will be running through the loop. So we will be first checking 10. So since the stack is empty, I will be printing -1. So my stack was empty, I printed -1, and then I will be pushing this element 10 into my stack. So my top pointer points to 10 now. Then I will be moving to the next element, 5. My stack is not empty right now, so I will be checking if my top pointer is greater than topmost element in fact, is greater than 5 or not. So it's greater than 5, so I print the topmost element and push 5 into the stack. Then I will be moving on to 12. The topmost element is not greater than 12. So what do I need to do? I will pop the topmost element. I get now the top pointer points to 10. Again, I check for is the topmost element greater than 12? No, it isn't. So I can pop the element out. So then I get an empty stack. So I will be now printing -1, because I said initially that if my stack is empty, I will be printing -1. So now I will be pushing 12 into my stack. Similarly for 6, if you see, the topmost element is greater than 6. So I'll print the topmost element and then push 6 into my stack. Then for 7, I will be checking again. Now 6 is less than 7, so I will be popping out 6, and then now 12 is greater than 7, so I will be printing 12 and then pushing a 7 to the stack. So let's now code this and check the time complexity. Okay. So let's consider my stack, sorry, the initial array to be some ARR, and I will be initializing it, with those array that the numbers that I was using earlier itself, and st is pointing to my top pointer. Now I'm coding in Python because it does not I do not need to write explicit functions to work with stacks, or I do not need other libraries to work with stack, unlike in Java and C++. So mm, that it just makes my work easier. You can use any language you want. Now my top pointer, as I said earlier, it will be -1, and then I need to store the answer somewhere, the whatever I need to print. So I will be storing it in this answer list. So let us run a loop in the initial numbers and this initial array. So now the first condition that I need to check is if my stack is empty or not. So if my stack is empty, what I need to do, I need to print -1. So I will append this -1 into my stack, into my answer array. Now I will be checking if my topmost element is greater than the array element. So if it's greater, then what I need to append is the topmost element, which is st of top. Now, if it's not greater, like you remember the number 12 case or the number 7 case, so we need to run a loop. Uh, for how long we need to run the loop is while there are elements in your stack, like your stack is not empty. So it would be top greater than -1, and then basically we will be writing the condition negated to this one. So st of top is less than equal to array of I. What do I need to do? I need to pop out the elements. So I will say your stack dot pop, and if you're popping out elements, we need to decrement the counter. That's it. Now remember the number 12 example where there were no elements left. So we will check for that condition. If your top is equal to -1, I will say my answer is -1, answer dot append -1, and else I will append the topmost element. What is topmost element? st of top. Now you must be remembering that after every whatever we have to give the answer, we had to append, like we have to push the element to our stack. So we will be pushing stack dot append your ERR of I, the element that we are checking, and then if you're appending the element, we need to add 1 to it and then print it. We'll print the answer. Yeah, so it's 10 -1. Sorry, it's for 10 it's -1. For 5 it has to be 10. For 12 again it's -1. For 6 it's 12, and for 7 it's again 12. So now looking at the code, you must be thinking that this code is also again giving the time complexity of O of n square. So what is the advantage of this stack approach? But you're wrong, because one thing that you can note is that every element is pushed and popped at most once. Like it will be pushed at most once and popped at most once. So there are actually two n operations that are being carried on, and each operation, like n pop operations and n push operations at max. So each operation takes O of 1 times a time. So the time complexity becomes O of n, and it's not O of n square. So that's why this reduces the time complexity by a great factor. So that's why if you use this approach, you can overcome your time limit exceeded errors. Most of you must have faced this time limit exceeded error while solving questions. So mm, even I have faced a lot, and I used to wonder that why is this? Because this the simplest approach is this. So if you use stacks, you can overcome this error. So I'll wait for 2 minutes. If you have any any questions on this, you can ask in the chat box. Mm, yeah, there is a straightforward implementation for data structures in Python, because Python, we don't need to specify the size of the list when we are declaring the list. That's why we can use the normal list in Python, and then the append works as the push operation, and the pop that I just used in my code works as your pop operation. For queue also it works similarly. There's not much a difference. So Python gives a much easier approach to data structures than other languages. Uh, yeah, so you can remove from the front by using st. Or okay, I'll type in the chat box. It's say I've typed in the chat box. It says st.pop zero, like it removes it from the front. So you can implement queues as well using stack in using a Python. Why do you need to keep the block empty? Like the queue, we'll come to that as well when we are discussing queues. Yeah, the length will reduce. Yes, Python is a slower language compared to C++ and Java, but I generally use Python, and there are very few questions where you can face a problem if you use I mean, if you're using Python. Generally, it does not give an that much issue if you're optimizing your code. Like maybe some in some of the sites the double dimension, like the two nested looping loops might work, but for Python it wouldn't. But if you're optimizing your code, I think any of the language will work. In C++, you have to use STL. So if you're quite familiar with STL and you have a good hold over it, then you can definitely use STL. Okay, we'll move forward. Mm, okay. So similarly, like I discussed about the nearest greater element to the left, you can find the nearest element, smaller element to your left as well. And another very similar question is the nearest smaller element to your right. So when you're checking for your elements on the right, what you need to do is, okay, I'll just discuss this input and output. So if you've been given an array like 5, 7, 2, 4, 3, for 5, the nearest smaller element is going to be 2. For 7, it's going to be 2 again. For 2, there's no other element on its right which is less than 2, so we'll be printing -1. For 4, we'll be printing 3, and for 3, again, it's -1. So the approach that you can use is you can just reverse the array. So it gives 5, 7, 2, 4, 3 gives 3, 4, 2, 7, 5, and then find the nearest smaller element to the left array. Like we were making the answer array, so you can find the answer array of this list, and then you can reverse this list as well, and it would be giving you the answer. So we'll move forward. This is one very interesting problem which says the stock span, which is called the stock span problem. What the problem statement is that you've been given an array of stock prices. Over here you can see 50, 30, 45, 65, 35. You need to find the maximum number of consecutive days just before the given day. Like for 45, you need to find the maximum number of consecutive days just before 45, for which the price of the stock on the current day, like the price of 45, is less than or equal to the price on the given day. How it works, for 50, there is no other day before it, so we will be printing 1. So because the number of days 1, which is the first day itself. For 50, we'll again be printing 1 because for 30 we'll again be printing 1 because 50 is again greater than 30. So there's one day which is consecutive, and the price is less than or equal to the given day. For 45, this third day as well as this second day, which is 30, because 50 is again greater than 45. So we will be printing 2. For 65, we'll be printing 1, which is this fourth day, then 45, 2, 33, and 54. So our answer will be 4. And for 35, again, we'll be printing 1 because 65 is greater than 35. So, how can you solve this question is, we can solve this by finding the nearest greater to left element. So, how it is done is, for 50, since there is no other element towards it, what you were originally printing for the nearest greater element on your left, -1. So, 0 minus of -1, so it gives me 1. For 30, okay, so there's a twist in this question is that we are not no more interested in the value of the greater element. We are interested in the index of the greater element. Like you can see in 30, the nearest greater element index is 0. So we will be subtracting it from the index of 30, which is 0, 1, 1, and 1 minus 0 is 1 itself, so 1. So for 45, the nearest greater element index is 0, and the index of this is 2. So 2 minus 0 is 2. For 65, it is the nearest greater element, there's no other element, so we will be subtracting -1 from the index. So 0, 1, 2, 3. 3 minus of -1, it will give me 4. And for 35, again, this is 0, 1, 2, 3, 3, and 4 minus 3, it will give me 1. This is how we will be solving this. So let us go to the coding part of this. Just remove this. Originally my array was, what is my array? Just a minute, I'll see. 50, 30, 45, 65, and 35. We will be taking a stack as usual. Our n will be 5 because there are 5 elements in the array. Now, as I said before, that we will be interested in the index of the greater element and not on the element. So we here I will be taking one more stack basically to store the index elements. Obviously, there's no necessity for two stacks. You can work with only the index stack as well. But just to make it more clear, I'm using two stacks right now, and my top will be pointing to -1. Now I'll start the loop for uh, iron range n. Again the same condition, if top is equal to -1, I will say answer dot append I plus 1. Why I'm doing I plus 1 is because if the stack is empty, what we were doing is I minus of -1. So it actually means I plus 1 only. Elif if your stack of top the topmost element of your stack pointer is greater than the array, what shall we append? We shall append the index of the given element minus the index of the topmost element, which is stint of mm, your top. Yeah. Then we'll move ahead with the while loop. Top If your top is greater than -1 and if your top is less than equal to, we need to pop the element. So we will be popping from the stack, and we also need to pop it from the stack index. Yeah, pop. And if you've popped the element, we need to subtract 1 obviously, and then we will be checking if your top is empty. I mean your stack is empty, then we will be appending I plus 1, else we will be appending answer dot append the I minus index of the topmost element. And as usual, we have to append the elements to our stack, array of I and stind dot append I. Then we have to increment the top pointer as well, and then we'll print the answer. Oh, I'm so sorry, I didn't refine the array. Answer is equal to I made a syntax error over here. Yeah, so this was what we were looking for. For 50, there is only 1 day. For 30, there is again 1 day. For 45, there are 2 days. For 65, there are 4 days. And for 35, there's again 1 day. So this is how you solve this question. I'll wait for another minute over here. If you have any doubt in this question, you can ask in the chat box. Okay, I guess no one has a doubt, so we'll move forward. Uh, yeah, this is another very standard problem, that is the rainwater trapping problem. So in this problem, I'll say, I'll just give the problem statement. So you've been given a pile of bricks, and the language changes from question to question. So over here, you've been given a pile of bricks. Say this has one brick and this has two. There are no bricks over here. Then again, two bricks, one brick, zero brick, and that's on. So you've been given an array like the length of the bricks. You need to find the amount of water, unit of water that is stored by these bricks. Like you can see over here, you can store 1 unit of water. Then again over here, 1 unit, 2 unit, 1 unit. So in total, we can store 6 units of water over here. There are a number of ways to solve this, but I'll be discussing the stack approach to this. So basically, what we are going to do is we are going to find the number of units of water that each brick or pile can store over it, and then we're going to add sum up this list and print it. So over here, this will store zero unit. This will store one, then one, two, one, again zero, zero, then 1 unit. Then we move it. Then let's look at the solution to this. So for example, say for this third pile of brick basically, which is at the second index, what we're going to do is we will find the greater element to the right of the brick. So on the greater element to the right of this brick is 3. So it's 3. And then we'll find the greater element to the left of the brick, which is basically we are finding the nearest greater element to the left and the right. So it's again 1 over here. Now, then we will find the maximum of 1 and the greater element to the left, array element and the greater element to the left, and then the array element and the greater element to the right. So basically it's 3 comma array of 2, which is maximum is 3, and the maximum of 1 and 2 is again 2. So then we will be finding the minimum. Yeah, then we will be finding the minimum of these two that we've got. So 2 and 3, it's going to be 2. And then we will be subtracting it from the height of that particular brick pile. So it's 2 minus 2 is 0. So this stores 0. Let's see how it works for the first one. Sorry. Um, Yeah. So for the first pile of brick, we can see the greater element to the left is 2, and then we'll be finding the 2 comma array of, because it's the first one, so we cannot store, obviously we cannot store any amount of water over it, so it will be 0. For the second one, the greater element on the to the right is 2, and maximum of 2 and 0 is going to be 2, and on the left is 1, and maximum of 1 and 0 is again 1, and minimum of these two is 1, and then we'll be subtracting 0 from 1. So 1 minus 0 will give me 1, so it stores 1 unit of water. Similarly, let's see for this 0, 1, 2, 3, 4, fourth index. Fourth index, the maximum element on its right is 3, and maximum of 3 and 0 is going to be 3. On the right, sorry, on your left, it's 2 and 2, and the maximum element out of 2 and 0 is going to be 2. Now, minimum of 2 and 3 is going to give me 2, and 2 minus 0 will give me 2, so it stores 2 units of water. So this is how you're going to you're going to solve this question. Now let's move to the next question. This is maximum area histogram. Yeah, so in this question what happens is that you've been given some array of numbers which denotes the height of an histogram, or it can be rephrased at height of buildings. You need to find the maximum area of this histogram. How it's given, I'll show you. For example, this array has been given 6, 2, 5, 4, 5, 1, 6. You need to find the maximum area. Yes, so you can form rectangles in this histogram. Like over here, you can see this gray shaded part. So it forms this. So what's the area of this? It's 7 into 1 unit, which is 7. Then you can see the brown part. It spreads out to this. So 5 into 2, it gives me 10 units. Now you can see the blue shaded part. So it gives this is 3 into 4, 4 3s are 12. So it gives 12 units, and this is the maximum area that we can form from this. So what is your approach going to be is that we can find the index of the nearest smallest element or smaller element to the right, like we did in the stock span problem. We will find the index of the nearest, like for 4 we are solving. uh, we'll find the nearest element on its right. So index is this 5, 0, 1, 2, 3, 4, 5. So 5, and then index of the nearest smaller element to the left of it. So for 4 it is going to be the nearest smaller element is 2, so index of it is 1. We will now, to find the width of this histogram, we will subtract 5 minus 1 and then 1, because we need to find basically the area between these two. So 5 minus 1, so it gives me 3, and the height of this particular array is 4. So 3 into 4, it gives me 12. So what I just said you need to do for each of these histograms, like I just solved for the the third index basically. So you need to solve for all of these, and you need to find the maximum of all of the answers that you've got. Okay, so I'll stop here, and if you have any doubts, you can throw it in the chat box. Okay, so I think you guys don't have any doubts, and all the doubts that you've asked have been solved. So then that's it for the day. Thanks for being a part of this session. And if you have still any doubts, you can type it in the chat box. Others, you can leave the meeting. The attendance has been taken. We have downloaded the attendance.